So we have been working on three-dimensional figures, and we've talked about surface area. And surface area really is a measurement of the outside of a three-dimensional figure. Today we're going to talk about measuring the inside of a three-dimensional figure. So what we're talking about again is that we want to measure the space inside of the three-dimensional figure. So you can think of it essentially as I'm wanting to fill up a three-dimensional figure, and it's a measurement of how much it takes to fill it up. And when we do that, we think about how many cubes can we use to fill it up, because when you think about filling up a three-dimensional space, that's what you're filling it with. You're filling it with little cubes. That's what you're wanting to figure out, how many little cubes would fit of a certain size. So for example, if you look at these particular prisms, I want to see if you can figure out which one do you think is going to hold the most cubes. So notice what we're going to do here. You're going to start by thinking about, well, I can put one layer of cubes in here, and is that going to fill it? No, it's not quite all the way filled yet. So can you figure out how many cubes they're each going to take? And can you then figure out which one is going to hold the most cubes? Give that a try, see what you come up with, and then we'll look at it together. All right, now if you looked at this, you might have thought that B would hold the most because it's the tallest, but notice it actually doesn't, because it also has the smallest base. So looking at the other two, they actually both hold the same number, because even though prism A has a greater area on the bottom, it isn't as tall as prism C. And in fact, if we looked at those, we would notice that they both hold 24 cubes, because when we look, prism number 1 is going to hold one layer of 12 cubes, and then we can fit a whole extra layer of 12 more cubes, so a total of 24 cubes. Prism B is going to hold one layer that has 4 cubes in it, and then a second layer, a third layer, and a fourth layer to fill that. Prism C is going to hold 8 on the bottom layer, and then another 8 and another 8. So 3 eighths makes 24 cubes. So again, prism A and prism C both actually hold the same amount. And this may have been pretty easy for you to see how we came up with those measurements. If you look at this, we could see, well, the base is 4 units wide, rather, for figure A. It's 4 units, and it is 3 units of depth. So we could think length and width or depth, it doesn't matter. So 3 units this way, and then it's going to be, so we measured this way, and now we're measuring this way. So the 3 times 4 tells us how many cubes would fit along the bottom, and then the height tells us how many layers of that number of cubes we need. So we need 2 layers because it's 2 units tall. So really all we're doing there is we're multiplying 4 times 3 times 2. So length times width times height is really all that we're doing. And you can put that in any order: width times length times height, height times length times width. It doesn't matter. Commutative property says that they're all going to give you the same answer, because we can multiply in any order, we're going to get the same answer. So let's look at some examples. And these are all rectangular prisms, or cubes. We could do a cube this same way. We're just doing rectangular prisms right now. See if you can find the volume of each of those, and then in just a minute we'll use the magnifying glass to check and see if you are correct. All right, so for the first one, it's going to have a volume of 195 cubic yards. And it's going to have that volume because we're going to do volume equals length times width times height for a rectangular prism. So volume equals 6 5/10 times 6 times 5. And when we work that out, we're going to get 195 cubic yards. And again, it's cubic yards because we're really measuring how many cubes will fit inside. If you did the others, you should have gotten 1,320 cubic centimeters, 198 702 thousandths cubic meters, and 8,645 cubic millimeters. All right, now let's look at this a little bit more. Let's talk about this. What if I asked you to create a prism or box that has a specific volume? Could you do that? Well, let's think about that a minute. If I want it to be a volume of 18 cubic centimeters, we know that we're going to have to do length times width times height. So we're really looking then for a combination of numbers that when I multiply them are going to give me 18. See what you can come up with. All right, one solution that would work is that we could have a length of 3 centimeters, a width of 2 centimeters, and a height of 3 centimeters. Because 3 centimeters times 2 centimeters is going to tell us I'm going to have a base area of 6 square centimeters, and then I'm going to need 3 layers of that. I need it to be 3 centimeters tall. Now notice I said something a little bit different than what I've said before. We've looked at volume equals length times width times height, and that's accurate, but we could also write that as volume equals base area, that's big B, times H. And I say that because doesn't length times width give you the area of the base of this prism? So 3 times 2. It's a rectangle that's 3 centimeters by 2 centimeters. So you actually can also think of the formula for area of a prism as base area times height. Let's look at one more example. If I asked you to find if I told you that this prism has a volume of 48 cubic inches, and I asked you what the height is, well, when you look at this, if the length is 2 and the width is 4, what I know is that the volume has to equal length times width times height. So if I fill in the things that I know that the volume is 48, I know that the length is 2, I know that the width is 4, I don't know the height. But 2 times 4 is 8, so it's 8h equals 48. I can solve this as an equation, and when I do, I need to divide by 8 on each side, and I'm going to get that my height is equal to 6 inches. So the height in this case is 6 inches. Again, notice how I used what I know about algebra to help me with that as well. Hopefully that's given you a good overview of volume of a rectangular prism. It's really pretty simple. Length times width times height, or thinking of the area of the base and then multiplying it by the height. And the reason we multiply it by the height is it tells us how many layers we're going to need to have that are the size of that base.